Imagine this. It's the year 2180. A geologist, working somewhere in what used to be North America, is drilling down through layers of rock. She's looking at sediment that formed back in our time, the early 21st century, and she finds something strange. A thin layer, dark, compressed, made almost entirely of synthetic polymers that nature never invented. Plastic, billions of tons of it, now fossilized into a geological marker that will exist for hundreds of millions of years. She makes a note in her report. Anthropocene boundary layer, she writes. Clear evidence of industrial civilization. And then she keeps drilling. Because that's her job. To go deeper. To see what came before. But here's where it gets interesting. What if she finds another layer? Deeper. Older. Different materials. Maybe. But the same signature. The same sudden spike in weird chemistry. The same hint that something happened here. Something that doesn't quite fit the narrative we've been told. Would she recognize it? Would she even know what she was looking at? That's the question that keeps me up at night. Not whether ancient aliens built the pyramids. Not whether Atlantis was real. But something much simpler and much stranger. How do we know we're the first? My name is Mr. H. And I want to tell you about a question that NASA scientists asked themselves in 2018. Not because they believed in conspiracy theories, but because they were genuinely curious about something that should concern all of us. They asked, how would we know if there had been industrial civilizations on Earth before humans? What evidence would survive? What would we even look for? The paper was published in the International Journal of Astrobiology. Real science. Real journal. The lead author was Gavin Schmidt, director of NASA's Goddard Institute for Space Studies. His co-author was Adam Frank, an astrophysicist from the University of Rochester. They called it the Silurian hypothesis. The name comes from an old Doctor Who episode about intelligent reptiles who evolved before humans. But the question behind it was completely serious. If an industrial civilization existed on Earth, say 100 million years ago, what traces would remain? What could we actually find? The answer they came up with should disturb you. Almost nothing. After 100 million years, everything we think of as permanent isn't. Cities crumble. Metal oxidizes. Plastic breaks down into particles so small they vanish into the geological noise. Even nuclear waste, which we think of as dangerously eternal, becomes undetectable after enough time has passed. The continents themselves move. Subduction zones pull entire tectonic plates back down into the mantle, melting them, recycling them, erasing whatever was on the surface. The ocean floor completely renews itself every 200 million years or so. Everything gets wiped clean. So if there was a civilization before us, we wouldn't find their cities. We wouldn't find their roads or their machines or their monuments. Deep time doesn't care what you built. It only cares what you changed in the chemistry of the planet itself. And that's where it gets really interesting. Because when Schmidt and Frank looked at what our civilization is doing right now, they realized we're leaving a very specific signature. A spike in carbon dioxide, a layer of synthetic materials, a sudden shift in nitrogen isotopes from industrial fertilizer, traces of plutonium and other elements that barely exist in nature, a scar in the geological record that says, something happened here, something burned a lot of carbon very quickly, something changed the chemistry of the atmosphere and the ocean in the span of just a few centuries. And then they asked the follow-up question. Have we seen anything like this before? Are there other moments in Earth's history where the carbon cycle went haywire? Where temperatures spiked for no clear reason? Where the isotope ratios don't quite make sense? The answer is yes. Not many. But yes, there's an event called the Paleocene-Eocene thermal maximum. It happened about 56 million years ago. Temperatures shot up by 5 to 8 degrees Celsius in just a few thousand years. Carbon flooded into the atmosphere. The ocean became more acidic. Species went extinct. Scientists have explanations for it. Volcanic activity. Methane release from melting permafrost. Totally natural processes. But here's the thing about scientific explanations. They're based on what we think is possible. And what we think is possible is based on what we've seen before. We've never seen an industrial civilization collapse and leave a geological signature, so we don't know what that would look like in deep time. We're guessing, educated guessing, but still guessing. The Silurian hypothesis doesn't claim there were ancient civilizations. Schmidt and Frank were very clear about that. They were doing a thought experiment, asking, what would the evidence look like, and would we recognize it if we saw it? But once you start thinking about it, you can't stop, because the implications are staggering. If civilizations are possible at all, and if Earth has been habitable for billions of years, and if intelligence has emerged at least once that we know of, why only once? What makes us so special? Life has been on this planet for at least 3.5 billion years. Complex life for over 500 million years. Dinosaurs dominated for 165 million years. We've been here for maybe 200,000 years, and industrial for only about 200. We are a blip, a geological instant. And we think we're the first ones smart enough to build cities and burn fossil fuels? That takes a certain kind of confidence, doesn't it? Now, I want to be clear about something. I'm not sitting here telling you there were dinosaur engineers or secret civilizations that mainstream science is hiding from you. I'm not interested in easy answers or comforting conspiracies. I'm interested in honest questions. And the honest question is, how much do we really know about deep time? How much can we know? The fossil record preserves maybe 1% of all species that have ever existed. We've explored less than 1% of Earth's crust. The ocean floor, which covers 70% of the planet, has been mapped in less detail than the surface of Mars. We're looking at the history of life through a keyhole, and we're making confident statements about what's in the room. That should make us humble. It should make us curious. And maybe, just maybe, it should make us wonder what else we've missed. So that's where we're going tonight. Down into deep time, into the layers of rock that hold secrets we might not have the tools to read, into the possibility that we're not the first experiment Earth has tried. We're going to look at the evidence, both mainstream and controversial. We're going to explore the limits of what we can know, and we're going to sit with the uncomfortable possibility that the story we tell ourselves about human uniqueness might be just that, a story. Before we go any further, I should mention something. If you're using this video to help you fall asleep, that's perfect. That's exactly why I make these. So maybe go ahead and subscribe, turn your screen brightness down, and drop a comment telling me where you are in the world and what time it is right now. I love knowing there are people all over the planet, lying in the dark, wondering about the same strange questions I wonder about. All right, let's keep going, because the next question is the one that really matters. If an industrial civilization could vanish from the geological record in 100 million years, what would actually survive? What traces are permanent enough to last? So here's the problem with looking for ancient civilizations. It's not that we don't have the tools or the curiosity. It's that geology doesn't care about preserving your story. Let me put this in perspective. Earth is 4.5 billion years old. If you compress that entire history into a single 24-hour day, modern humans would appear at about 4 seconds before midnight. Recorded human history, everything from the pyramids to the internet, would be the last fraction of the last second. Industrial civilization, we wouldn't even register. A flash, a blink, gone. That's deep time. The problem is erosion. Wind, water, ice, chemical weathering. They never stop. Mountains that took millions of years to form get worn down to nothing. The Appalachian Mountains used to be as tall as the Himalayas. Now they're gentle hills. Erosion took hundreds of millions of years to do that. But it did it. And that's just on land. Underground is worse. Or better, depending on how you look at it. Because underground, you've got something called plate tectonics. The Earth's crust is broken into massive plates that float on the semi-molten mantle below. These plates move, slowly, just a few centimeters per year. And when they collide, one plate usually gets shoved underneath the other in a process called subduction. The plate that goes under gets pulled down into the mantle, where it melts. Everything on it, Everything in it gets destroyed, recycled, turned back into magma. The ocean floor is constantly being created at mid-ocean ridges and destroyed at subduction zones. The oldest ocean floor on Earth is only about 200 million years old. Everything older than that is gone, erased, pulled back into the mantle, and melted down. So if there was a civilization on a coastal plain 250 million years ago, and that coastal plain happened to be on oceanic crust, there would be literally zero evidence remaining. Not because we haven't looked, because the evidence no longer exists anywhere in the physical universe. It's been unmade, even on continental crust, which sticks around longer. You've got problems. Burial, metamorphosis. Continental crust can get buried under kilometers of sediment. The heat and pressure down there changes rock at a fundamental level. Sandstone becomes quartzite, limestone becomes marble. Any fossils, any chemical signatures, any trace of what was there before gets scrambled or erased entirely. The Earth is constantly rewriting its own history, and it doesn't keep drafts. So when Schmidt and Frank did their analysis, they were trying to figure out what could actually survive this process. What leaves a mark that's permanent enough to last 100 million years or more? Here's what they came up with. First, isotope ratios, specifically carbon isotopes. There are different types of carbon, different weights. Carbon-12 and carbon-13 are the common ones. Living things prefer carbon-12 because it's lighter and easier to use in chemical reactions. So when you burn a lot of organic material, like fossil fuels, you release carbon that has a specific isotopic signature, more carbon-12 relative to carbon-13. That ratio gets preserved in certain types of rock, carbonates, marine sediments, even in the fossils of tiny organisms that lived in the ocean and absorbed that carbon into their shells. And here's the interesting part. We do see anomalies in the carbon isotope record, times when the ratio shifts suddenly, when carbon-12 floods the system for reasons that aren't entirely clear. The Paleocene-Eocene thermal maximum I mentioned earlier is one example. 56 million years ago, the carbon cycle went haywire, temperatures spiked, the ocean acidified, and the isotope ratios show a massive injection of carbon-12 into the atmosphere. The mainstream explanation is methane. Huge reserves of methane trapped in permafrost or under the ocean floor got released, maybe triggered by volcanic activity or some other natural process. Methane is organic, so it has that carbon-12 signature. Release enough of it fast enough, and you get the pattern we see in the rocks. That explanation makes sense. It fits the data. But here's the thing. So would an industrial civilization burning through its fossil fuel reserves in a few centuries. The signatures would be nearly identical. I'm not saying the PETM was caused by ancient industry. I'm saying we wouldn't necessarily be able to tell the difference. That's what makes this so unsettling. Second thing that survives. Synthetic materials. Plastics, obviously, but also metals in unusual concentrations or combinations. Industrial processes create alloys and compounds that don't really occur in nature. Stainless steel, aluminum oxide ceramics. Certain types of glass, these materials can break down, absolutely, but they break down into particles. And those particles have chemical signatures that are distinct from natural minerals. We're creating a sediment layer right now that's full of microplastics, tiny fragments that have spread to every corner of the planet. They're in the Arctic ice. They're in the Mariana Trench. They're in the rain that falls on remote mountains. They're inside our bodies. In 100 million years, those microplastics will be compressed into a thin, dark layer in the sedimentary rock. Future geologists would call it the Anthropocene boundary layer, if there are future geologists. But would they recognize it if they saw a similar layer from, say, the Cretaceous period? Maybe not. Because we don't know what materials a non-human civilization would use. Maybe they never invented plastic. Maybe they used something else entirely. Something that degrades into particles we'd just think were natural minerals. Third thing, radioactive isotopes. Nuclear fission creates isotopes that essentially don't exist in nature. Plutonium-239, cesium-137, strontium-90. These have very specific half-lives and very specific signatures. We've scattered these isotopes all over the planet through nuclear testing, through accidents like Chernobyl and Fukushima, through normal operation of nuclear power plants, that signature will be detectable for millions of years in certain rock formations. But here's where it gets weird. There's a place in Gabon, in West Africa, called Oklo. In 1972, French scientists were analyzing uranium ore from Oklo and found something impossible. The uranium had been depleted. It had less uranium-235 than it should have. After a lot of head-scratching, they figured out what happened. About 2 billion years ago, conditions at Oklo were just right for a natural nuclear reactor to form. Uranium ore, groundwater acting as a moderator, and the right geological setup. Nuclear fission occurred naturally, sustaining itself for hundreds of thousands of years. It's the only known natural nuclear reactor on Earth. But when it was first discovered, before they understood what they were looking at, some people wondered. Because the isotope ratios looked engineered. They looked like someone had run a reactor there. Now, Oklo is definitely natural. We understand the mechanism. But it shows you how tricky this gets. Nature can mimic technology, and technology, after enough time, can look like nature. So if you found another geological formation with weird uranium ratios, how would you know? How would you tell the difference between a natural reactor and an artificial one that's been sitting there for 200 million years? You probably couldn't. Not with certainty. Fourth thing that might survive. Mass extinction events. If an industrial civilization collapsed, there would probably be ecological consequences. Species dying off. Ecosystems collapsing. That would show up in the fossil record as a sudden loss of biodiversity. But mass extinctions happen naturally too. Earth has had at least 5 major ones. The most famous is the one that killed the dinosaurs 66 million years ago. Massive volcanic eruptions in India. The combination was catastrophic. We've also got smaller extinction pulses. Times when a significant percentage of species disappeared relatively quickly. Not all of them have clear explanations. Some are blamed on volcanic activity, some on climate shifts, some on asteroid impacts we haven't found evidence for yet. But if a civilization industrialized too fast and collapsed ecologically, it would look a lot like a natural extinction event in the fossil record, especially after tens of millions of years of erosion and subduction had erased the finer details. Fifth thing. Nitrogen isotopes. This is a newer area of research, but it's fascinating. Industrial agriculture uses synthetic nitrogen fertilizer, made through the Haber-Bosch process. This creates nitrogen with a very specific isotopic signature, different from biological nitrogen fixation. That signature washes into the ocean and gets incorporated into marine sediments. If we found a layer of sediment from, say, 150 million years ago with weird nitrogen isotope ratios, would we investigate it? Or would we just assume it was some natural process we don't fully understand yet? The honest answer is, we'd probably assume it was natural, because that's the simpler explanation. That's Occam's razor. The explanation that requires the fewest assumptions is usually correct, but usually isn't always. And here's the thing that really gets me. We've only been doing detailed geochemical analysis of ancient rock for a few decades. We're still developing the tools, still figuring out what questions to ask. There could be anomalies sitting in the data right now that we don't recognize as anomalies. Patterns we think are natural because we haven't considered any other possibility. In science, you tend to find what you're looking for. If you're not looking for evidence of ancient industrial civilizations because you think it's absurd, you're not going to find it. That doesn't mean it is there, but it means we should be humble about what we think we know. The geological record is like a book that's been burned, shredded, scattered across the ocean floor, and then had 99% of the pages dissolved in acid. A few paragraphs here and there, and from those fragments, we're trying to reconstruct the entire story of life on Earth. We're doing pretty well, all things considered. We've figured out an incredible amount. Evolution, plate tectonics, mass extinctions, climate cycles. It's genuinely impressive, but we should never forget how much is missing. How much has been erased by the simple passage of time. Deep time doesn't care about your accomplishments. It doesn't care about your monuments, or your literature, or your scientific discoveries. It cares about what you changed in the chemistry of the planet, and even that, it slowly erases. There's something both humbling and terrifying about that. The idea that everything we build, everything we create, everything we think is so important could vanish so completely that future intelligences might not even know we existed, unless they knew what to look for, unless they asked the right questions, and that's what we're trying to do here. Ask the right questions. Look at the evidence with fresh eyes. Consider possibilities that seem absurd until you really think about them, because the universe has surprised us before, and it'll surprise us again. Before we go deeper, a quick thought. If you're finding this interesting, a like helps other curious minds find these questions too. And if something I've said sparked a thought or reminded you of some mystery you've heard about, share it in the comments. I read every single one. I'm genuinely curious what you're thinking. All right, let's keep digging. Now let's talk about things we can actually see and touch. Not geological anomalies or isotope ratios. I'm talking about physical structures, ancient buildings and artifacts that exist right now, that archaeologists have measured and studied, and that still don't quite make sense. These aren't fantasies, they're real. The debate isn't whether they exist. The debate is about who built them, when, and how. Let's start with Göbekli Tepe. It's in southeastern Turkey, and it's probably the most important archaeological discovery of the last 50 years. When it was excavated in the 1990s, it completely overturned what we thought we knew about the development of civilization. Göbekli Tepe is a massive stone complex, huge T-shaped pillars, some weighing up to 16 tons, arranged in circular formations. The pillars are decorated with intricate carvings of animals: foxes, scorpions, vultures, snakes. The craftsmanship is sophisticated. Whoever made this knew what they were doing. Here's the problem. It's 11,600 years old. That's important, because according to the traditional timeline, humans at that point were hunter-gatherers. We hadn't invented agriculture yet. We didn't have cities or permanent settlements. We were nomadic bands moving around, following game, gathering plants. The development of civilization was supposed to go like this. First agriculture, then surplus food, then specialization of labor, then organized religion and monumental architecture. Göbekli Tepe does it backwards. Monumental architecture first, agriculture came later. They hadn't figured out animal husbandry, but somehow they organized the labor to quarry, transport, and erect these massive stones. And they did it with stone tools. No metal, no wheels, no draft animals. Mainstream archaeology has accepted Göbekli Tepe as real. It's not controversial anymore, but it forced a complete rethinking of how civilization develops. It suggests that organized religion and communal construction projects might have come first, and agriculture developed as a response to the need to feed people gathering for these ritual sites. It's an elegant theory. It might even be true, but it also opens a door that makes some archaeologists uncomfortable. If we were wrong about this, what else might we be wrong about? Let's move to Egypt. The Great Pyramid of Giza. You've seen pictures. You think you know what it is, but the precision of its construction is genuinely difficult to explain, even today. The base of the pyramid is a square. Each side is about 230 meters long. The difference in length between the longest and shortest side is less than 2 centimeters. 2 centimeters over 230 meters. That's an error of 0.008%. The base is also nearly perfectly level. The southeast corner is only 1.3 centimeters higher than the northwest corner, over a base that covers 13 acres. Try to imagine leveling 13 acres of limestone bedrock to within 1.5 centimeters using copper tools and stone pounders. Because that's what they supposedly had. No steel, no lasers, no sophisticated surveying equipment. And it gets weirder. The pyramid is aligned to true north with an accuracy of 3.4 arc minutes. That's about 0.06 degrees off. To achieve that, you need to understand astronomy and have a method for determining true north with extreme precision. There are theories about how they did it, astronomy-based methods using stars, careful observation and mathematics. The Egyptians were sophisticated. They absolutely could have done this. But here's what bothers me. We don't actually know how they did it. We have theories. educated guesses. We've found some tools, we've found some evidence of ramps and construction techniques, but nothing that fully explains the precision. Nothing that explains how they maintained such tight tolerances over such a massive structure using the technology we think they had. And before you say aliens, stop, I'm not going there. They had geometry, astronomy, engineering knowledge that we're only now beginning to fully appreciate. They didn't need aliens. But maybe, just maybe, they had knowledge or techniques that we've lost. Methods that weren't written down or weren't preserved. That's not crazy. That's just honest. Let's go to South America. Bolivia. A place called Puma Punku. Puma Punku is part of a larger complex called Tiwanaku. It's at 13,000 feet elevation on the Altiplano near Lake Titicaca. The site is at least 1,400 years old, maybe older. Mainstream archaeology dates it to around 600 AD. What's strange about Puma Punku is the stonework. These aren't rough-cut blocks. They're precision-cut pieces of andesite and diorite, some of the hardest stones on Earth. The blocks have flat surfaces, sharp angles, complex interlocking shapes. Some of the cuts are so precise that they look machine-made. Perfect right angles, smooth surfaces, intricate grooves, and channels cut into stone that ranks between 6 and 7 on the Mohs hardness scale. The people who built Puma Punku supposedly didn't have iron tools. They had copper, bronze, and stone. Copper and bronze are too soft to efficiently cut andesite. Stone tools would work, but incredibly slowly, and wouldn't give you the precision we see. There are theories. Maybe they used harder stones to shape softer stones. Maybe they had techniques we haven't discovered. Maybe the precision isn't as remarkable as it looks, and it's just unusual weathering patterns. But when engineers and stonemasons look at Puma Punku, they scratch their heads. Because even with modern equipment, replicating some of those cuts would be challenging. It seems nearly impossible. I'm not saying it was impossible. Clearly someone did it. The stones are there, but the gap between the tools we think they had and the results they achieved is significant enough to warrant curiosity, not dismissal. Then there's Baalbek in Lebanon, the Roman temple complex built on top of much earlier foundations. Those foundations include something called the trilithon, 3 massive stone blocks, each weighing somewhere between 800 and 1,000 tons. 1,000 tons. That's 2 million pounds. Per block. These stones were quarried half a mile away, transported to the site, and lifted into place about 20 feet off the ground. This happened at least 2,000 years ago, possibly much earlier. For comparison, the largest stones used in the Great Pyramid weigh about 80 tons. The trilithon stones are more than 10 times heavier. There's another block still in the quarry at Baalbek. It's called the Stone of the Pregnant Woman. It weighs approximately 1,200 tons. It was partially cut out of the bedrock but never moved. You can still see it there, sitting at an angle, waiting for transport that never happened. Modern cranes can lift 1,000 tons, but you need specialized equipment. Heavy lift cranes, massive counterweights, careful engineering, and you're not moving it very far. How did ancient people do it? Nobody knows. There are theories about sleds, rollers, massive teams of workers, but nothing has been demonstrated practically. Nobody's successfully moved 1,000-ton stone using ancient techniques because honestly, we don't know what those techniques were. The Romans took credit for the Baalbek complex, but they might have just built on top of foundations that were already there. The style of the trilithon is different from typical Roman construction. It might be much older. Let's go underwater. Because some of the strangest structures aren't on land anymore. They're submerged. Off the coast of Japan, near Yonaguni Island, there's a rock formation that looks like a stepped pyramid. Sharp angles, flat surfaces, what appear to be carved channels and right-angle cuts. It was discovered in 1986 by a dive instructor. The geologist who studied it most, Masaki Kimura, believes it's a man-made structure that sank due to earthquakes or sea level rise. He points to features that look like post holes, carved figures, and tool marks. Other geologists, including Robert Schoch from Boston University, Think it's a natural formation shaped by erosion and tectonic activity. Sandstone can fracture along straight lines. Water erosion can create flat surfaces. Here's the thing. It could be both. It could be a natural formation that was modified by humans, carved, shaped, used for some purpose. If it is artificial, it would have to be at least 10,000 years old, because that's when sea levels were low enough for it to be above water. 10,000 years ago puts it in the same time frame as Göbekli Tepe. And there are other underwater structures. Off the coast of India, in the Gulf of Cambay, sonar has detected what appear to be geometric structures. Off Cuba, off the coast of Spain, none have been thoroughly investigated because underwater archaeology is expensive and difficult, but the ocean has risen over 300 feet since the last ice age. Huge areas of coastal land are now underwater. If there were settlements on those coasts, and there almost certainly were because coasts are prime real estate, they're gone. Buried under sediment, we've barely looked. Now, I want to talk about something smaller, the Antikythera mechanism. It's in a museum in Athens right now. You can go see it. It was found in a Roman shipwreck off the Greek island of Antikythera in 1901. For decades, nobody knew what it was. A corroded lump of bronze with gears inside. As technology improved and we could scan it without destroying it, we figured it out. It's a computer. A mechanical computer from around 100 BCE. Maybe earlier. It has at least 30 bronze gears in a complex arrangement. It was used to predict astronomical positions, eclipses, the cycles of the moon and planets. The level of miniaturization, the precision of the gears, the complexity of the mechanism. Nothing else like it appears in the historical record for over 1,000 years. We have one single example, found by accident in a shipwreck. How many didn't survive? How many were melted down for the bronze? How many are sitting in sediment at the bottom of the Mediterranean? The Antikythera mechanism proves that ancient people were capable of creating technology far more advanced than we generally give them credit for. And if we only have one example, what does that say about how much we've lost? I'm not saying any of this proves ancient civilizations more advanced than our own. I'm not saying aliens visited Earth and taught people how to cut stone. I'm saying we have a consistent habit of underestimating our ancestors, of assuming that because they didn't have computers and steel, they must have been primitive, that they couldn't have achieved things that puzzle us today. But these structures exist. These artifacts are real. And the gap between what we think they could do and what they clearly did do, that gap should make us humble. It should make us curious. Maybe they were just really, really good at things we've forgotten how to do. Maybe craftsmanship and knowledge can reach heights we don't expect when people dedicate generations to a single problem. Or maybe the timeline we've constructed is incomplete. Maybe there's more to the story than we've been willing to consider. Either way, the stones are there, waiting, asking questions we're still trying to answer. So let's talk about the idea that's captured human imagination for thousands of years. The lost civilization. The advanced culture that came before us and vanished, leaving only myths and ruins. It starts with Atlantis. Of course it does. The story comes from Plato, Greek philosopher, writing around 360 BCE. He mentions Atlantis in two of his dialogues, Timaeus and Critias. According to Plato, Atlantis was a powerful island nation that existed 9,000 years before his time. It was advanced, wealthy, militarily strong, and then, in a single day and night, it sank into the ocean and disappeared. Now here's the question that's been debated for over 2,000 years. Was Plato describing a real place, or was he making up an allegory? A fictional story meant to illustrate philosophical points about pride and the fall of civilizations. Most scholars think it was allegory. Plato was making a point about Athens and the dangers of imperial overreach. He invented Atlantis as a cautionary tale, but some people read it and thought, what if he was preserving a real memory? What if there was a kernel of historical truth buried in the story? That question has never gone away. It spawned thousands of books, documentaries, expeditions. People have looked for Atlantis everywhere. In the Bahamas, nobody's found it. At least, not anything that matches Plato's description convincingly. But the desire to find it, the need to believe it existed, that tells us something important about ourselves. We want there to have been something before us. Some golden age we fell from, some knowledge we lost. That's a pattern that shows up across cultures. The idea that we're not at the beginning of the story, that we're in the middle, or maybe near the end, of a much longer cycle. In the 19th century, there was a theory called Lemuria, sometimes called Mu. It was proposed to explain how similar species existed on different continents. Maybe there was a lost continent in the Indian or Pacific Ocean that served as a land bridge. Then we discovered plate tectonics and realized continents don't just sink. They move slowly, sure, but they don't disappear into the ocean like Atlantis supposedly did. Lemuria was debunked scientifically, but it persists in alternative history circles, in occult traditions, in certain spiritual movements, because the idea resonates emotionally, even if the geology doesn't support it. Now let's talk about Graham Hancock. Because love him or hate him, he's probably the most influential voice in lost civilization theory today. Hancock is a journalist, not an archaeologist. He's written extensively about the possibility of an advanced civilization that existed during the last ice age and was destroyed by a cataclysm around 12,800 years ago. His most famous book is Fingerprints of the Gods, published in 1995. It's been a bestseller for decades. Millions of copies sold. His Netflix series Ancient Apocalypse was hugely popular, despite being heavily criticized by archaeologists. Here's his basic argument. Around 12,800 years ago, something catastrophic happened. A comet or asteroid impact, possibly multiple impacts. This triggered rapid climate change, massive flooding, the extinction of megafauna like mammoths and saber-toothed cats. He calls it the Younger Dryas impact hypothesis. And here's the interesting part. There's actually scientific debate about whether this impact happened. In 2007, a team of researchers led by Richard Firestone published a paper claiming they'd found evidence of an extraterrestrial impact at the start of the Younger Dryas period. They found nanodiamonds, which form under extreme pressure. They found high concentrations of iridium, which is rare on Earth but common in asteroids. They found a layer of black sediment across North America and Europe that suggested widespread fires. The Younger Dryas was a real climate event. We know that for certain. About 12,800 years ago, Earth suddenly got cold again, right in the middle of warming up from the last ice age. It stayed cold for over 1,000 years, then warmed rapidly. The question is, what caused it? Mainstream science generally points to changes in ocean circulation. The North Atlantic current shifted, disrupting heat distribution, natural climate variability. But the impact hypothesis has support from some legitimate scientists. Not all, maybe not even most, but enough that it's still being researched and debated in peer-reviewed journals. So where does Hancock come in? He takes this potential impact event and adds another layer. He suggests that before this cataclysm, there was an advanced civilization, not as advanced as us technologically, maybe, but advanced in ways we don't fully appreciate: maritime navigation, astronomy, mathematics, architecture. This civilization, according to Hancock, was global, or at least widespread. When the impacts hit and the ice melted rapidly, sea levels rose by hundreds of feet. Coastal settlements were drowned. The civilization collapsed. Most people died, but some survivors spread out, carrying their knowledge to different parts of the world. They became the teachers, the civilizers, the gods of local myths. They taught astronomy to the Egyptians, architecture to the Sumerians, agriculture to the people of Göbekli Tepe. That's why, Hancock argues, we see similar myths across cultures. Flood stories, gods who came from the sea to teach wisdom, lost golden ages. They're all memories of the same event, filtered through thousands of years of oral tradition. And sites like Göbekli Tepe, they're evidence. Settlements built by survivors, or by people the survivors taught. That's why the sophistication appears suddenly in the archaeological record. It wasn't developed slowly, it was inherited. Now, here's what mainstream archaeology says about this. They say there's no physical evidence, no cities, No metal tools or pottery or textiles that clearly predate the established timeline. If there was a global civilization, we should find something. But we don't. They say the similarities between cultures can be explained by the fact that humans are humans. We all look at the same sky. We all experience floods and earthquakes. We all tell stories to make sense of trauma. Similar myths don't require a common source. They just require common humanity. They say that Hancock cherry-picks evidence. He highlights anomalies that support his theory and ignores the overwhelming evidence that fits the mainstream narrative. That's not good methodology. That's confirmation bias. And they're not entirely wrong. Hancock does make leaps. He does speculate beyond what the evidence strictly supports. He admits this. He calls himself a journalist, exploring ideas, not a scientist proving hypotheses. But here's what bothers me about the dismissal. Archaeologists sometimes act like the absence of evidence is evidence of absence. They say we haven't found proof of a lost civilization, therefore there wasn't one. But as we discussed earlier, after enough time, evidence disappears. Especially evidence from coastal settlements, which is exactly where an advanced maritime civilization would have lived. And those coasts are now underwater. We've explored less than 5% of the ocean floor in any detail, less than 1% with the kind of resolution that would detect archaeological sites. Maybe there's nothing there. Maybe Hancock is wrong. But the certainty with which he's dismissed sometimes feels more like protecting territory than pursuing truth. And there's something else. Something Hancock talks about that makes mainstream archaeology uncomfortable. Indigenous knowledge, oral traditions, stories passed down for generations, native accounts of cataclysms, floods, fires from the sky. For a long time, these stories were dismissed as mythology, primitive attempts to explain natural phenomena, not real history. But we're learning that's arrogant. Australian Aboriginal oral traditions describe the flooding of coastal areas as sea levels rose at the end of the Ice Age. For years, these stories were considered myths. Then geologists confirmed that yes, those areas were above water during the Ice Age and flooded as the ice melted. The stories were preserving real events over 10,000 years. So when Native American tribes talk about the sky falling and the earth shaking and fire raining down 12,000 years ago, maybe we should listen. Maybe oral tradition can preserve memories across spans of time we didn't think possible. That doesn't mean every detail is accurate. Memory gets distorted. Stories get embellished. Symbolism replaces literalism, but it means there might be truth there. Historical truth, not just mythological truth. Here's what I find most interesting about the lost civilization hypothesis. Not whether it's right or wrong, but why it appeals to us so deeply. I think it's because it offers meaning. It suggests that human history is more than just a slow climb from ignorance to knowledge. It suggests there are cycles, rise and fall, golden ages and dark ages. It makes our current civilization feel less special, but also less alone. We're not the first to ask these questions. We're not the first to build, to wonder, to reach for something greater. And if they fell, if they were destroyed by forces beyond their control, well, that's a warning, isn't it? It says, be careful, be humble, you're not as secure as you think. There's comfort in that, strangely. The idea that our struggles have been struggled before, that our fears have been feared before. It makes us feel connected to something larger than ourselves, a human story that spans not just centuries but tens of thousands of years. Maybe that's why these theories persist despite academic rejection. Not because people are stupid or gullible, but because they're hungry for connection, for meaning, for a story that says, you're part of something ancient and vast and mysterious. And honestly, I don't think that hunger is something to mock. I think it's something to understand, because whether or not there was a lost civilization 12,000 years ago, the questions it raises are worth asking. The humility it encourages is worth cultivating. We don't know everything. We haven't found everything. And the story of humanity might be stranger and longer than we've been taught. That possibility, just the possibility, is worth sitting with for a while. So let's turn this around for a moment. Let's stop asking what ancient civilizations might have left behind and ask, what are we leaving behind? Because we're in the middle of creating our own geological signature right now. First, let's talk about concrete. We've produced more concrete in the last 20 years than in the entire 20th century before that. We use about 30 billion tons of it per year. That's 4 tons for every human on Earth. Every year. All that concrete is going to be here for a very long time. It'll crack, it'll crumble, it'll get buried under sediment, but it won't disappear. In 100 million years, there will be a layer in the geological record that's just full of concrete particles. A distinctive marker that says, something built a lot of artificial stone here, but concrete is nothing compared to plastic. We've created about 8 billion tons of plastic since the 1950s. Most of it is still here. Plastic doesn't biodegrade in any meaningful time frame. It breaks down into smaller and smaller pieces, but it doesn't go away. Microplastics are everywhere now, and I mean everywhere. They've been found in Arctic ice cores, in the Mariana Trench, 7 miles down in the deepest part of the ocean, in the snow on Mount Everest, in the rain that falls on supposedly pristine wilderness areas. They're inside us, in our blood, in our lungs, in our brains. When we're gone, when our cities are dust and our monuments are eroded away, the microplastics will remain, compressed into sedimentary layers, a thin dark band that future geologists, if there are any, would recognize as deeply unnatural. Plastic in the geological record. That's our legacy. Then there's what some scientists call the technosphere. That's everything humans have built. All the mass we've moved around and transformed. Buildings, roads, machines, products, waste. A recent study calculated that human-made mass now exceeds all living biomass on Earth. Everything we've built weighs more than all the trees, all the plants, all the animals, all the bacteria. Combined, we've rearranged the surface of the planet. We've moved more sediment through mining and construction than all the rivers and glaciers move naturally. We've become a geological force. And here's something strange and specific. Chicken bones. No, really. Modern broiler chickens are bred to grow so fast and so large that they're anatomically different from wild chickens or even chickens from 50 years ago. Their bones are thicker, denser, shaped differently to support unnaturally large breast muscles. We slaughter about 65 billion chickens per year globally. 65 billion. Their bones end up in landfills, in compost, scattered across the landscape. A paper published in 2018 argued that broiler chicken bones should be considered a marker species for the Anthropocene. Future paleontologists would find these distinctive bones in sedimentary layers and know, breeding them for specific traits, raising them by the billions. It's absurd and tragic and kind of perfect. Our geological marker species might be the chicken. Let's talk about cities. What happens to a city after we're gone? There's been some interesting research on this. Within a few hundred years, most buildings collapse. Steel corrodes. Concrete cracks and crumbles when the rebar inside rusts and expands. Glass breaks. Wood rots. Within a few thousand years, you'd barely recognize that a city had been there. Nature reclaims everything surprisingly fast, but the foundations remain. The basements, the subway tunnels, the sewer systems. These get filled with sediment, but their shapes persist. Their outlines. In 10 million years, you might find strange geometric formations in the rock, regular patterns, right angles where right angles don't occur naturally. You just wouldn't know what or why. And then there's the nuclear layer. This is probably our most distinctive and permanent signature. From 1945 to 1963, we conducted over 2,000 nuclear weapons tests, mostly above ground. Those tests scattered radioactive isotopes across the entire planet. Plutonium-239, cesium-137, carbon-14 in unusual ratios. You can detect this layer in ice cores, in tree rings, in sediment. It's a clear boundary marker. The planet itself is different now in a measurable way. Then there were the accidents. Chernobyl in 1986, Fukushima in 2011. Those sites will be radioactive for thousands of years. The isotope signatures will last much longer. Even normal operation of nuclear power plants leaves traces. Tritium in the water, isotopes in the air. Nothing dangerous at the levels we're talking about, but detectable. In 100 million years, a geologist could drill down and find elevated levels of plutonium-239 in a specific layer of rock. Something had nuclear technology. That's assuming they knew what plutonium-239 was and what it meant. If they didn't, it would just be a chemical anomaly, something weird in the isotope ratios. Which brings us back to the central question. If we're leaving such a clear signature, and if an ancient civilization had industrial technology, why haven't we found their signature? Maybe we have, and we don't recognize it. Maybe there are anomalies in the chemical record that we're attributing to natural processes because we haven't considered any other explanation. Or maybe they didn't use the same materials we use. No plastic, no concrete. Maybe they built with something organic that biodegraded completely. Maybe their technology was fundamentally different in ways we can't imagine. Or maybe there weren't any ancient industrial civilizations and this whole thought experiment is just that. A thought experiment. But here's what strikes me, the irony of it. We're creating a geological layer that will last for hundreds of millions of years. A layer that screams, intelligence was here, technology was here, and we're doing it almost by accident. We're not trying to leave a message for the future. We're just living, consuming, building, making stuff. Most of what we build for ourselves. For right now, we don't think about deep time. We don't think about what archaeologists 100 million years from now might find. We're leaving a very clear signature, but not the one we'd choose if we were trying to communicate. Not the one we'd want to be remembered by. Future intelligences won't find our art. They won't find our literature, or our music, or our scientific papers. Those are too fragile. Information stored on paper, on hard drives, in the cloud. It all decays. They'll find plastic particles and chicken bones and elevated plutonium levels. They'll know we were here. They'll know we changed things, but they won't know who we were, what we valued, what we dreamed about. There's something deeply sad about that. The idea that all of human achievement, all of Shakespeare and Einstein, and every person who ever loved someone, or created something beautiful, it all gets reduced to a chemical anomaly in the rock. But that's deep time. It doesn't care about your intentions. It doesn't care about your values. It only records what you changed in the physical world. And what we're changing is the climate, the oceans, the composition of the atmosphere. We're leaving a mark that future geologists would call a boundary event. Something happened here. Something changed the carbon cycle. Something warmed the planet. Something caused a lot of species to go extinct in a very short time. If we found that pattern in the Cretaceous, we'd look for explanations. Volcanoes, asteroid impacts, natural climate cycles. Would we consider the possibility of industrial civilization? But future geologists looking at our layer won't have to wonder. The signature is clear. The evidence is everywhere. The cause is obvious. Intelligent technological civilization was here. That's what we're leaving. Not wisdom, not a warning, just evidence that it happened. The question is whether anyone will be around to find it, whether we survive what we're doing to the planet, whether we figure out how to live sustainably before we collapse. Because here's the thing about geological signatures. They record what happened. They don't record whether you learned from it. If another intelligence rises millions of years from now, maybe they'll find our layer. Maybe they'll study it. Maybe they'll ask, what were they thinking? Did they know what they were doing? And the answer in the rock will be, yes, they knew. They had the science. They had the data. They kept doing it anyway. That's the signature we're leaving. And I don't know about you, but that keeps me up at night. Not because I think we're doomed. I don't know if we're doomed, but because I think we could do better. We could be more intentional about what we leave behind. We could think about deep time, about what future archaeologists might find, about what story the rocks will tell. We could try to leave a different signature, one we'd be proud of, but that would require thinking beyond ourselves, beyond our lifetimes. And that's hard. That's maybe the hardest thing, to care deeply about a future you'll never see, to make sacrifices for people who don't exist yet. But maybe that's what separates a wise civilization from one that just happened. The ability to see yourself as part of something larger, something that extends deep into the past and deep into the future. To hold that perspective while still living your life, still finding joy, still creating. That's the challenge. That's what we're struggling with right now. And the rocks are watching, recording, waiting to tell our story. Okay, so this is where it gets fun, where we let imagination play with science for a bit. Not to prove anything, but just to see what happens when you ask a question nobody's really asked before. What if the dinosaurs had engineers? I know how that sounds. I know the first thing that pops into your head is some terrible science fiction movie with velociraptors wearing lab coats. That's not what I'm talking about. I'm talking about a serious thought experiment proposed by serious scientists who wanted to explore the limits of what we can know about deep time. Remember that paper I mentioned at the beginning? The one by Gavin Schmidt from NASA and Adam Frank? They named it after a Doctor Who episode from the 1970s. In that episode, there was an intelligent reptilian species that evolved on Earth millions of years before humans. They called themselves Silurians, though technically they would have been from a different geological period. Doctor Who wasn't great with the geology, but the name stuck. The Silurian hypothesis. The question of whether we could detect an industrial civilization from the age of dinosaurs or earlier. And here's why it's worth asking, even if it sounds absurd. Dinosaurs dominated this planet for 165 million years. They survived multiple mass extinctions. They spread to every continent. They evolved into thousands of species, from tiny feathered creatures to the largest land animals that ever lived. Humans? We've been around for maybe 200,000 years, and we've only been industrial for about 200. We're a blip, a footnote, a geological instant. So purely from a statistical standpoint, if intelligence can evolve, if tool use and civilization are possible outcomes of evolution, why would it only happen once in all that time? Why would we be special? Now, before you answer, think about what we mean by intelligence. We don't mean human intelligence specifically. We mean problem solving, tool use, social organization, the ability to manipulate the environment in deliberate ways. We've seen that in lots of species. Crows use tools. Octopuses solve puzzles. Dolphins have complex social structures and communication. Elephants mourn their dead and remember locations across decades. Intelligence isn't unique to humans. It's a spectrum. We're just at one end of it, the end that happened to develop language and abstract thought and opposable thumbs in the right combination. But who's to say that combination couldn't have occurred before? In a different species? Under different evolutionary pressures? Dinosaurs had a lot of time, a lot of different environments, a lot of evolutionary experimentation. Some showed evidence of parental care, which suggests social bonding. Could one lineage, somewhere in those 165 million years, have developed something we'd recognize as civilization? Here's where the thought experiment gets interesting. What would we look for? Schmidt and Frank went through it systematically. If there was an industrial civilization during the Cretaceous period, say 80 million years ago, what traces would remain? Not buildings, not artifacts, not fossils of the creatures themselves, because fossilization is rare and we've found such a tiny percentage of all the dinosaurs that ever lived. What you'd look for are chemical signatures, the same things we talked about earlier. Carbon isotope excursions, temperature spikes, elevated nitrogen levels, unusual metal concentrations, extinction events. And here's the uncomfortable part. We've found some of those things. There are several periods during the age of dinosaurs when the carbon cycle went strange. Times when carbon dioxide levels spiked, temperatures rose rapidly, and the ocean became more acidic. They're called oceanic anoxic events. The ocean loses oxygen. Marine life dies off in massive numbers. The chemistry goes haywire. The most famous one is called OAE2, about 93 million years ago. It lasted for about 500,000 years. Carbon isotope ratios went weird. Temperatures spiked by several degrees. Something like 27% of marine invertebrate species went extinct. The mainstream explanation is volcanic activity, massive eruptions releasing carbon dioxide and other gases. Natural climate cycles amplifying the effect. It makes sense. It fits the data. But so would an industrial civilization that burned through its fossil fuel reserves, collapsed, and left the planet to recover over hundreds of thousands of years. The signatures would be nearly identical. That's the point Schmidt and Frank were making. We couldn't tell the difference. Not after 93 million years of geological processing. There are other carbon anomalies scattered through the Mesozoic era. Not all of them have clear explanations. Most are attributed to volcanism or ocean circulation changes or methane release from warming oceans. All plausible, all natural, all possible, but we're seeing them through the lens of what we think is possible. And what we think is possible doesn't include industrial dinosaurs because that seems ridiculous. Except, is it ridiculous? Or is it just unfamiliar? We know dinosaurs could be smart. Some theropods, the group that includes velociraptors and eventually evolved into birds, had brain-to-body ratios comparable to modern birds. Crows and ravens are scary smart. They use tools. They plan for the future. They hold grudges. If you gave crow intelligence 60 million years to evolve in different directions under different pressures, what might you get? I'm not saying you'd definitely get civilization. I'm saying you might. And if you did, and if that civilization industrialized and collapsed 80 million years ago, we wouldn't know. The fossil record for that period is incredibly sparse. We have fragments, pieces, individual specimens from species that existed for millions of years across entire continents. If one species in one region developed technology and lasted for, say, 50,000 years before collapsing, what are the chances we'd find a fossil of them? Close to zero. And even if we did, how would we recognize it? We're looking for bones, for teeth, for the physical remains of the animal. We're not looking for evidence of behavior, for tool marks on other fossils, for unusual concentrations of worked materials, because we're not expecting to find those things. We're not designed our searches around looking for them. There's a concept in science called the streetlight effect. A drunk man loses his keys in a dark alley, but he looks for them under the streetlight because that's where he can see. We look for evidence where our methods can detect it, not necessarily where the evidence actually is. We're looking under the streetlight. And industrial dinosaur civilizations, if they existed, are in the dark alley. Now, let me be very clear. I don't believe there were industrial dinosaurs. I'm not arguing for that. The evidence doesn't support it, and the absence of any clear artifacts or traces suggests it didn't happen. But what I find valuable about this thought experiment is the humility it forces on us. We barely understand our own geological signature, and we're creating it right now. We can watch it happen. We can measure it in real time. And still, there are debates about exactly what traces will last, what future geologists would be able to detect, how they'd interpret what they found. If we're uncertain about our own signature, how can we be certain we'd recognize someone else's from 100 million years ago? We can't. That's the honest answer. The absence of evidence isn't evidence of absence. It's just absence of evidence. Or maybe they were and we don't know how to see them. There's something deeply humbling about that. The idea that the universe might contain mysteries we don't even know are mysteries. Questions we haven't thought to ask. Evidence we're not equipped to recognize. It reminds me that certainty is often just a failure of imagination. We're certain about things because we can't conceive of alternatives. Not because we've ruled out all alternatives. And in a universe as old and strange as ours, that's probably not a good stance to take. I like sitting with uncertainty, with the possibility that we might be wrong about fundamental things, not in a paranoid conspiracy theory way, but in an open, curious, humble way. What if intelligence is more common than we think? What if it arises and falls in cycles? What if Earth has been running experiments in consciousness for hundreds of millions of years, and we're just the latest iteration? that doesn't make us less special. It makes us part of something larger, something ancient, a pattern that repeats across deep time. And if we're part of a pattern, maybe we can learn from it. Maybe the traces left by previous iterations, if they exist, contain lessons, warnings, or maybe not. Maybe we're alone. Maybe intelligence is so rare and fragile that it's only happened once, and we're it. I don't know which possibility is more frightening, being alone or being part of a cycle of rise and fall that we can't escape, but I know which one makes me feel more connected to the planet, more humble about our place in the story. The idea that we're not the pinnacle, we're just another chapter, another attempt, another experiment in what consciousness can do when it gets access to opposable thumbs and abstract thought. The dinosaurs had their time. They ruled the planet longer than any mammal ever has. They saw continents split and oceans form. They survived mass extinctions and climate swings that would terrify us. And maybe, somewhere in all that time, some of them looked up at the stars and wondered. Maybe some of them asked questions. Maybe some of them built something. Or maybe they didn't. Maybe they just existed, eating and reproducing and dying, like most life does. Either way, their time ended. An asteroid or volcanoes or both, and the age of dinosaurs was over. And millions of years later, these tiny mammals, barely surviving in the margins, began to evolve. That's where we are. Wondering. Looking back through deep time with imperfect tools and incomplete evidence, trying to see what was there. And honestly, I think the wondering is more important than the answer. The humility is more valuable than the certainty. Because whether or not there were industrial dinosaurs, the question reminds us how much we don't know, how much we can't know, and that's a good thing to remember. Especially when we're so confident about everything else. There's a story that shows up everywhere, across continents, across cultures that had no contact with each other, told in different languages by people who lived thousands of miles apart. It's the story of the flood. In the early 1980s, an anthropologist named Alan Dundes documented over 500 flood myths from cultures around the world. 500. That's not a coincidence. That's not independent invention happening hundreds of times by accident. That's memory. Collective memory. The kind that gets passed down through generations because it was important, because it was traumatic, because people needed to remember. Let me tell you some of these stories. The oldest written version we have is from Sumeria, about 4,000 years old. It's called the Epic of Gilgamesh. In it, the gods decide to destroy humanity with a great flood. But one man, Utnapishtim, is warned by the god Ea. He builds a boat, takes his family, takes animals. The flood comes. It lasts 6 days and 7 nights. The boat lands on a mountain. Utnapishtim sends out birds to find dry land. Sound familiar? The Hebrew Bible has the story of Noah. Same basic structure. God decides to flood the earth. Noah is warned. He builds an ark, takes his family and animals. The flood lasts 40 days and 40 nights. The ark lands on Mount Ararat. Noah sends out birds. But it's not just Middle Eastern cultures. In Hindu tradition, there's the story of Manu. The god Vishnu appears as a fish and warns Manu that a great flood is coming. Manu builds a boat. The flood destroys all other life. Manu's boat is tied to a mountaintop by the fish. Manu repopulates the earth. In ancient Greece, there's Deucalion. Zeus sends a flood to destroy humanity because of their wickedness. Deucalion and his wife Pyrrha are warned by the titan Prometheus. They build a chest, a kind of boat. They float for 9 days. They land on Mount Parnassus. They repopulate the earth by throwing stones that become people. In China, there's the story of Gunyu. A great flood covers the land. Gun tries to stop it and fails. His son Yu succeeds by dredging channels to direct the water. He becomes a legendary emperor. Native American traditions are full of flood stories. The Ojibwe tell of a time when the world was covered with water. Only a few people survived on a raft with animals. They sent animals down to find earth. Finally, the muskrat succeeded and brought up mud, which became the new land. The Aztecs believed the world had been destroyed and remade multiple times. One of those destructions was by flood. In Australian Aboriginal tradition, there are stories of the land being swallowed by the sea. Specific locations, specific coastal areas that were once above water and are now gone. I could go on. Polynesia, Africa, South America. Every inhabited continent has flood stories. They vary in details, but the core is the same. Water came, it rose, it destroyed. Now, here's the question. Why? For a long time, the answer from scholars was, floods are common, rivers overflow, tsunamis hit coasts. People experience local flooding and mythologize it into a global event. Each culture invented their own flood myth independently, because floods are a universal human experience. That's a reasonable explanation. It makes sense, but it doesn't quite fit the pattern. Because these stories aren't just about floods. They're about the world ending, about everything being destroyed, about a complete reset of civilization, and they often include specific details. The flood came suddenly. The water rose incredibly high, covering mountains. Almost everyone died. Knowledge was lost. The survivors had to start over. That's not a local river flooding. That's something bigger, something more traumatic. So what actually happened? Well, we know that sea levels rose dramatically at the end of the last ice age. About 20,000 years ago, sea levels were about 400 feet lower than they are today. Huge areas of what's now ocean floor were dry land. Coastlines were completely different, and then the ice melted. Not slowly and steadily, but in pulses. There's an event called Meltwater Pulse 1A. It happened about 14,600 years ago. Sea levels rose between 16 and 40 feet in less than 500 years, possibly much faster, maybe in just a few decades. Can you imagine? You live on the coast, your family has lived there for generations, and over your lifetime, the sea rises 40 feet. The gathering places, the sacred sites, gone. Then there's Meltwater Pulse 1B, about 11,500 years ago. Another rapid rise, more coastal settlements drowned. And remember the Younger Dryas event we talked about earlier? The potential comet impact around 12,800 years ago? That would have caused massive flooding too, not just from sea level rise, but from the sudden melting of ice, from tsunamis if there were ocean impacts, from the disruption of weather patterns. A geologist named Randall Carlson has spent decades studying the landscape of North America. He's documented evidence of catastrophic flooding from glacial melt. Enormous channels carved through bedrock, massive boulders moved hundreds of miles, features that could only have been created by floods of almost unimaginable scale. The channeled scablands in Washington state, carved by water, moving faster and with more volume than all the rivers on Earth combined. That flood happened about 15,000 years ago when a glacial lake dam broke. People lived through this. They had to. We know humans were in North America by at least 15,000 years ago, probably earlier. They would have witnessed these floods, survived them, remembered them, and that memory would have been passed down, generation to generation, becoming story, becoming myth, becoming warning. What's remarkable is how accurate oral tradition can be. We used to dismiss indigenous stories as primitive myth. Now we're learning they can preserve real events across thousands of years. Those Australian Aboriginal stories about the sea rising and swallowing the land. Geologists have confirmed those areas were above water during the Ice Age and flooded between 7,000 and 12,000 years ago. The stories were right. They preserved actual historical events across 10,000 years of oral tradition. So when cultures around the world tell stories of a great flood that destroyed the world, maybe they're not inventing mythology. Maybe they're remembering not a single global flood that covered the entire Earth. That didn't happen. We know that. But regional catastrophic flooding? Sudden sea level rise that destroyed coastal settlements? That absolutely happened. And if humans were living on those coasts, and they almost certainly were because coasts are the most productive environments, then those settlements are gone now. Underwater, buried under sediment, lost. We've barely explored the submerged coastlines. The technology to do underwater archaeology at scale is relatively new. We're finding things, but slowly. And here's what makes me wonder. If there were sophisticated settlements on those coasts, settlements with knowledge and culture and possibly even early forms of writing or record keeping, they're gone now. The flood stories might be preserving memory of real civilizations that were lost. Not Atlantis exactly. Not some super advanced culture, but possibly more advanced than we give our ancestors credit for. People who built in wood and other organic materials that don't preserve. People who navigated by stars and understood astronomy. People who had oral traditions and knowledge systems that were destroyed when the floods came, and the survivors spread out, inland, to new regions, carrying their stories, their memories, their knowledge. Is that so hard to believe? Is it really more likely that 500 different cultures independently invented nearly identical flood myths? Or is it more likely that something real happened? Something traumatic? And the memory of it spread and persisted across human cultures? I think we know the answer. Because if oral tradition can preserve real events across 10,000 years, then maybe we should listen more carefully to the stories indigenous peoples tell. Maybe the myths aren't just primitive attempts to explain the world. Maybe they're history. Distorted by time, yes. Embellished with supernatural elements, sure, but rooted in real events. The gods didn't send the flood, but the water rose. People died. Settlements were destroyed. Knowledge was lost. And the survivors remembered. They told their children. Who told their children? Who told their children down through hundreds of generations. The details changed. The reasons changed. The supernatural explanations got added. But the core remained. Water came. That's what myths do. They preserve what matters. What was so important, so traumatic, so world-changing, that it had to be remembered. The flood stories are telling us something, not about divine punishment or moral lessons, though those got layered on top. They're telling us that our ancestors lived through catastrophe, that the world they knew ended. And maybe, just maybe, they're warning us. Because the water is rising again. Ice is melting again. Coasts are flooding again. This time we know why. This time we're causing it. But the pattern is the same. Humans living on coasts, water rising, time running out. Our ancestors survived it. They adapted. They moved. They rebuilt. Can we? That's the question buried in these old stories. Not just what happened, but what we learned from it. What we carried forward, and whether we're still listening to the warnings encoded in our oldest memories, because the flood always comes. In one form or another, the world always changes. The question is whether we're ready, whether we remember, whether we tell the right stories to our children so they'll know what to do when the water rises again. Let's zoom out for a moment, all the way out, to the biggest question we can ask. Where is everybody? That's the Fermi paradox, named after physicist Enrico Fermi, who supposedly asked it during a casual lunch conversation in 1950. The question seems simple, but it contains multitudes. There are billions of stars in our galaxy. Billions of galaxies in the observable universe. Many of those stars have planets. Some of those planets are in the habitable zone where liquid water can exist. The universe is about 13.8 billion years old. Our Sun is only 4.6 billion years old. That means there are stars billions of years older than ours, with planets that had billions of years more time for life to develop. If intelligent life is at all common, the universe should be teeming with civilizations. Some of them should be millions or billions of years more advanced than us. They should have spread across the galaxy. We should see evidence of them everywhere, but we don't. The sky is silent. No radio signals. No megastructures. No signs of galactic engineering. Nothing. Where is everybody? There are lots of potential answers. Maybe intelligent life is incredibly rare. Maybe we're alone, or nearly alone. Maybe they're out there but hiding. Maybe they're here but we don't recognize them. But there's another framework for thinking about this, and it ties directly into everything we've been talking about. The idea is that somewhere between simple chemistry and galaxy-spanning civilizations, there's a filter, a barrier that almost nothing gets through, something that prevents the universe from being full of advanced life. And here's the terrifying question. Is the filter behind us or ahead of us? If the filter is behind us, it means the hard part is already done. Getting from non-life to life, from simple life to complex life, from complex life to intelligence, from intelligence to technology. Those steps are so improbable, so difficult, that almost nothing makes it through. But we did. We're the rare ones. We're the lottery winners. And if that's true, then the future is wide open. We can spread to the stars. We can become ancient and wise. We can be one of the precious few intelligences in the universe. That's the optimistic interpretation. But if the filter is ahead of us, that's different. That means getting to where we are isn't that hard. Life probably emerges lots of places. Intelligence probably develops fairly often. The hard part is surviving. The hard part is not destroying yourself once you have technology. And if that's true, then our future looks darker, because it means every civilization gets to roughly our level, and then something happens. Something stops them. Something prevents them from becoming the ancient star-faring species we look for in the sky. What could that something be? Nuclear war is the obvious one. We came close during the Cold War. We still have enough weapons to create nuclear winter and collapse civilization. It wouldn't take much. A miscommunication, an accident, a leader who doesn't care about consequences. Climate change is another. We're running an experiment right now, burning through millions of years of stored carbon in just a few centuries, changing the atmosphere faster than most species can adapt. We don't know how this ends. Maybe we figure it out. Maybe we don't. Artificial intelligence is the newer concern. We're creating something that might become smarter than us, and we don't really understand how intelligence works, ours or artificial. We're moving fast, maybe too fast. Bioengineering, nanotechnology. There are lots of ways a sufficiently advanced civilization could accidentally destroy itself. Lots of technologies that could go wrong in catastrophic ways. Maybe the great filter is self-destruction. Maybe every civilization reaches a point where their technology outpaces their wisdom, where they can destroy themselves before they learn not to. And maybe that's why the sky is silent. Not because intelligence is rare, but because it's fragile, because it doesn't last. We might be looking at the night sky, wondering where everyone is, not realizing we're looking at a graveyard. Billions of civilizations that rose and fell and left no trace we can detect. That's a heavy thought. It sits with you, but there's another possibility. One that connects to everything we've been exploring. What if civilizations do destroy themselves, but not completely? What if they collapse back to a pre-industrial state, and the planet recovers, and millions of years later, intelligence evolves again? What if Earth has been through this cycle before? Think about it. If an industrial civilization collapsed catastrophically, if most of the population died, and the survivors lost access to advanced technology, what would happen? Within a few generations, you'd have people who remembered the old world, but couldn't recreate it. Within a few thousand years, it would be forgotten entirely. And the planet would heal. It always does. The carbon cycle would restabilize. New species would evolve to fill empty niches. The geological record would preserve only the faintest traces. Fast forward 10 million years, 100 million years. New species have evolved. Maybe one of them develops intelligence, starts asking questions, starts building. They wouldn't know about us. How could they? We'd be gone, erased by deep time. From their perspective, they'd be the first, just like we think we're the first. But maybe we're not. Maybe this has happened before. Maybe Earth runs experiments in consciousness. Maybe intelligence arises, flourishes briefly, collapses, and the planet waits and tries again. If that's true, we're not special. We're just the current iteration. And honestly, I find that comforting in a strange way. It takes the pressure off. We're not the pinnacle of creation. We're not the only chance the universe has. We're just us, doing our best, part of a larger pattern. It also means we're not alone in time, even if we're alone in space. There might have been others before us, asking the same questions, facing the same challenges. Did they solve them? Did they figure out how to survive their own technology? We don't know. If they did, where did they go? If they didn't, that's a warning we should probably pay attention to. There's a statistical argument here too. Life on Earth started almost as soon as the planet was cool enough to support it, about 3.8 billion years ago, just a few 100 million years after the late heavy bombardment, when asteroids were still pummeling the surface. That suggests life isn't that hard. Given the right conditions, it happens quickly, almost inevitably. And if life has emerged multiple times on Earth, as some scientists think it might have, then maybe intelligence has too. Maybe it's not as rare as we assume. We think of ourselves as the end point of evolution, the pinnacle, but evolution doesn't have endpoints. It just continues, branching, experimenting, trying new things. We're not the end of anything. We're a moment, a brief flowering, and when we're gone, whether that's in 100 years or 1,000,000 years, the planet will continue. Evolution will continue. Maybe something else will ask these questions someday. Maybe they'll find traces of us. Maybe they won't. Either way, the story continues. With or without us. And that's both terrifying and comforting, isn't it? The idea that we don't matter as much as we think, that the universe is bigger than our survival or extinction, but also that we're part of something continuous, something ancient, something that keeps trying, keeps experimenting, keeps reaching toward complexity and consciousness. We're not the first try. Maybe we're not even the best try. We're just this try, this moment, this brief chance for the universe to look at itself and wonder, and maybe that's enough. Maybe that's all it ever is. Temporary consciousness, brief flickers of awareness in the long darkness of deep time. We look at the silent sky and ask where everyone is. But maybe they're not out there. Maybe they're here, layered in the rock beneath our feet, compressed into geological signatures we don't know how to read. Maybe we're walking on the graves of previous attempts, previous civilizations, previous questions asked and answered or left hanging. And maybe millions of years from now, someone else will walk on ours. And they'll wonder. And they'll ask the same questions. That's the cycle. That's the pattern. Rise and fall and rise again. It doesn't make our moment less meaningful. It makes it more. Because we're part of something larger than ourselves. Part of a story that spans billions of years. We don't have to be the last. We don't have to be perfect. We just have to be here. Present. That's all any of us can do. That's all any civilization has ever done. Try, fail, learn, and hope it's enough. There's a concept I want you to try to hold in your mind. It won't quite fit. It's too big. But try anyway. Deep time. The writer John McPhee coined that phrase. He was trying to find words for something that doesn't have words. Time so vast that it breaks human comprehension. Time measured not in years or centuries or even millennia, but in millions and billions of years. 4.5 billion years. That's how old Earth is. Can you picture that? Can you really feel it? You can't. Neither can I. Our brains didn't evolve to grasp that kind of duration. It's like trying to see a color that doesn't exist. The equipment isn't there. Let me try to give you scale, though I know it won't work. If Earth's entire history was compressed into a single year, modern humans would appear at around 11:58 p.m. on December 31st. Recorded history would be the last few seconds before midnight. Everything we think of as ancient, the pyramids, the Roman Empire, the Renaissance, all of it happens in the final fraction of the final second. We're not even a blip. We're less than a blip. And yet we make such confident statements about what happened before us. We draw timelines. We create narratives. We say, this is when this happened. This is how long that took. This is what the world was like. Based on what? Based on fragments, traces, the tiniest sampling of what actually existed. The fossil record preserves maybe 1% of all species that ever lived. 1%. And that's being generous. Some estimates put it much lower. For every dinosaur we've found and named and put in a museum, there were thousands we'll never know about. Species that existed for millions of years and left no trace. Entire evolutionary lineages that appeared and disappeared without ever fossilizing. Most life doesn't fossilize. It decays. It gets eaten. It gets scattered and broken down. Only under very specific conditions do bones become stone. Do soft tissue leave impressions? We're looking at 1% of the story. Maybe less. And from that tiny fraction, we're reconstructing the entire history of life on Earth. It's remarkable that we can do it at all. It's a testament to human ingenuity and scientific method that we've figured out as much as we have. But we should never forget how much is missing, how much has been lost to time. There's a period in Earth's history called the Boring Billion, about 1.8 billion years ago to 800 million years ago. A full billion years where not much seemed to happen. Life existed, mostly simple life, bacteria, maybe some early complex cells, but no major innovations, no explosions of diversity, just existence. For a billion years. We call it boring because nothing dramatic shows up in the rock. No major evolutionary leaps, no mass extinctions, no climate catastrophes that we can detect. But was it actually boring? Or do we just not have the resolution to see what was happening? A billion years is a long time. Things must have been happening. Changes, experiments, failures, and successes. We just can't see them. The evidence is too subtle, or too eroded, or too transformed by heat and pressure. Deep time erases, it smooths. And then there are the gaps, the missing sections, the parts of the geological record that simply don't exist anymore. Subduction has destroyed all oceanic crust older than about 200 million years. Anything that happened on the ocean floor before that is gone, melted, recycled into the mantle, and the ocean covers 70% of the planet. 70% of Earth's surface has no geological record older than the dinosaurs. What happened there? What existed there? We'll never know. The evidence no longer exists in the physical universe. On land, erosion and burial have destroyed or hidden most of the record. We've explored less than 1% of Earth's crust in any detail. Less than 1%. The rest is inaccessible. Too deep. Too remote, too expensive to drill, too dangerous to reach. We're working with scraps, fragments, the barest outline of a story. And from these scraps, we make declarations. We say, intelligence only evolved once. Industrial civilization never happened before. We're the first. Maybe we're right. Probably we're right. But we should at least acknowledge the possibility that we're wrong. That there are things we've missed, things we couldn't see even if we looked directly at them, because the universe doesn't owe us clarity. It doesn't owe us answers. There's something peaceful about that realization. Once you accept it, once you stop demanding that everything be knowable, some things are genuinely beyond our ability to determine, not because we're not smart enough or don't have the right tools, but because the information is gone, erased by time, lost to entropy. No amount of research will recover it. And that's okay. It has to be okay, because the alternative is to drive yourself mad demanding answers that don't exist. I think about this sometimes late at night. The vastness of what we don't know, the enormity of the mystery. Not specific mysteries like was there an ancient civilization or what killed the dinosaurs. Those are solvable. Those are questions we can chip away at. I mean the deeper mystery, the fundamental unknowability of most of history, most of existence. The Cambrian explosion happened about 541 million years ago. Suddenly, relatively suddenly, complex life appeared in the fossil record. Animals with eyes and shells and different body plans. We don't really know why. We have theories. Changes in ocean chemistry, increase in oxygen, evolutionary arms races. But the truth is, We're guessing. Educated guessing, but guessing nonetheless. Because whatever triggered it, whatever the conditions were, they're buried under 500 million years of subsequent geology. We can't go back and check. We can't run the experiment again. We just have the results. Why? The rocks aren't saying, and this happens again and again. Mass extinctions where we don't fully understand the cause. Climate shifts that don't quite make sense. Gaps in the fossil record where entire lineages disappear. And we don't know if they went extinct or just stopped fossilizing. The honest scientific answer to so many questions is, we don't know. We have hypotheses. And that's fine. That's how science works. You admit what you don't know. You keep looking. You refine your understanding. But somewhere along the way, we started confusing we don't know with we'll never know. Some mysteries are temporary. We'll solve them eventually with better tools or new discoveries. But some mysteries might be permanent. The information might be gone. The evidence might not exist anymore. And learning to be comfortable with that, that's wisdom. That's maturity. Accepting that the universe is bigger than your ability to comprehend it. Deep time doesn't care if you understand it. It doesn't care if you can imagine it or hold it in your mind. It just continues rolling forward. Patient and vast and completely unconcerned with human curiosity. We get our brief moment, our tiny window. We look around. We ask questions. We piece together what we can from the fragments available to us. And then our moment ends, and deep time continues without us. Just like it continued before us. There were billions of years before we existed. There will be billions more after we're gone. Entire epochs. Entire eras. Entire chapters of Earth's story that we're not part of. And that's humbling. In the best possible way, it reminds you that you're not the center. You're not the point. You're just a participant. Brief, temporary, one consciousness among countless others that have flickered and faded. The universe is full of things we'll never understand, questions we'll never answer, mysteries that will remain mysterious forever. And somehow, that's beautiful. That's okay. That's exactly how it should be. Because if we could know everything, if we could understand everything, what would be left? What would there be to wonder about? The mystery is the point. The unknowing is the gift. It keeps us humble. It keeps us curious. It keeps us reaching towards something we can never quite grasp. And maybe that's enough. Maybe that reaching, that wondering, that acceptance of our own limits. Not to solve everything, just to notice, to pay attention, to witness the mystery for a little while, and then to rest. Deep time will continue. The story will go on. And that's perfectly, beautifully, terrifyingly fine. So after all of that, after deep time and lost civilizations and mysteries we'll never solve, after dinosaurs and floods and the silent sky, what does any of it mean for you? For us? For this moment? Right now, where you're listening to my voice in the dark? I think it means we can relax a little. Let go of some weight we've been carrying without realizing it. The weight of being special. Of being first. Of being the pinnacle of everything that came before. Because maybe we're not. And that's okay. That's more than okay. We're not the point of the universe. We're not the culmination of some grand design. We're not uniquely important in the cosmic story. We're just here. Part of something much larger and older and stranger than we can fully understand. And there's comfort in that. Real comfort. The kind that settles into your bones and lets you breathe easier. You don't have to carry the weight of human exceptionalism. You don't have to believe we're the only intelligence that ever mattered. You don't have to think everything depends on us getting it right. The universe was fine before we showed up. It'll be fine after we're gone. That's not nihilism. That's perspective. It takes the pressure off. It lets you be small. And being small, truly accepting your smallness in the vastness of time and space, that's not diminishing. That's freeing. You're part of a pattern. A continuation. Maybe there were others before us. Maybe there will be others after. Maybe consciousness keeps emerging and fading, like waves on a shore that's been there for billions of years. Each wave thinks it's unique. Each wave matters while it's happening. But then it dissolves back into the ocean, and another wave comes. That doesn't make your wave less beautiful. It makes it part of something eternal, the rise and fall, the attempt and the letting go. That's not failure. That's just the pattern. That's how it works. Our ancestors knew this better than we do. They understood impermanence. They built things knowing they wouldn't last. They told stories knowing the words would change. They lived knowing they were temporary, and somehow that made them wiser, more present, more willing to appreciate what they had while they had it. We've lost that. We want permanence. We want our mark to last forever. We want to be remembered. We want to matter in some absolute cosmic sense. But nothing lasts forever. Not pyramids, not plastic, not even stars. Everything that begins ends. Everything that rises falls. And once you accept that, really accept it, you can start to appreciate the moment for what it is. Brief, beautiful, unrepeatable. This moment right now. You, listening. Me, speaking. The darkness around you. The quiet. This is it. This is what we get. Not forever, just now. And now is enough. It always has been. If there were civilizations before us, they had their moment too. They looked at the stars. They asked questions. They wondered if they were alone. And then their moment ended. And the earth continued. And eventually, we appeared. And we're asking the same questions. That's the continuity. That's the thread that connects us across deep time. Not artifacts or evidence or proof. Just the wondering, the curiosity, the need to understand. Every intelligence that's ever existed probably felt that. That pull toward knowledge. That desire to make sense of things. We're not unique in that. We're part of a long tradition of consciousness asking, what is this? Why are we here? What came before? And maybe none of us get complete answers. Maybe that's not the point. Maybe the point is just to ask, to wonder, to pay attention for a little while. You don't have to solve the mystery of whether there were ancient civilizations. You don't have to figure out if we're alone in the universe. You don't have to understand deep time or the Fermi paradox or any of it. You can just be here, curious, open, willing to not know. That's enough. That's always been enough. There's an archaeological mindset I think about sometimes. It's this. Imagine yourself as a future fossil. Imagine someone millions of years from now finding some trace of you. What would you want them to find? What would you want the rocks to say about how you lived? Not monuments, not achievements, not proof that you were important. Just evidence that you were here, that you paid attention, that you cared about something. Maybe kindness shows up in the fossil record. Maybe gentleness leaves a trace. Probably not. Probably geology only records the big things, the chemical changes, the disruptions, but maybe that's okay too. Maybe your moment doesn't need to be preserved. Maybe it just needs to be lived, fully, presently, with whatever grace you can muster. The paradox is that you can care deeply about things while holding them lightly. You can love this world, this life, this moment, without needing it to last forever. That's what our ancestors understood. What indigenous cultures still understand. What we keep forgetting in our desperate attempt to be permanent. Nothing is permanent. Everything changes. Everyone you love will die. Every civilization falls. Every star burns out. And somehow, mysteriously, that doesn't make anything less precious. It makes it more. Because it's temporary. Because it's fleeting. Because this exact configuration of atoms and awareness will never happen again. You're here now. Part of the story. Part of the continuation. Connected backward to everything that came before. And forward to everything that will come after. You're a link in a chain so long you can't see either end. And that's beautiful. That's enough. You don't have to be special. You don't have to be first. You don't have to leave a permanent mark. You just have to be here. Awake. Aware. For as long as your moment lasts. And when it ends, when your wave dissolves back into the ocean, that's okay too. Because the ocean continues. The pattern continues. The story continues, with or without you. And there's peace in that. Real peace. The kind that lets you finally rest. Because you don't have to figure it all out. You don't have to save everything. You don't have to be more than what you are, which is enough. Which has always been enough. Which will always be enough. Just this. Just now. Just you. Breathing in the dark. Part of something so much larger than yourself. Connected. Continuous. Held by deep time and the vast patient turning of the earth. You're okay. You've always been okay. You're exactly where you need to be. And you can rest now. If you want, you've earned it. The mysteries will still be here tomorrow. The questions will wait. The universe is patient. You can let go. You can close your eyes. You can drift. You're safe. You're part of something eternal. So here we are. Back in this moment. Back in this room. Back to just you and the quiet and the darkness. We've traveled a long way tonight. Through deep time. Through lost civilizations and geological mysteries. Through floods and dinosaurs and the silent spaces between stars. But all of that, it can wait now. It's not going anywhere. The questions will still be there tomorrow. The mysteries will keep. Right now, there's just this. Just you. Just the softness of where you're lying. Just the rhythm of your breathing, slow and steady. You don't have to think about any of it anymore. You don't have to figure anything out. You don't have to hold on to anything. You can just let go. Let the questions drift away. Let the wondering fade. Let your mind get quiet and soft and still. You're safe here. Whatever room you're in, whatever time it is where you are, you're safe. The earth is turning beneath you like it's been turning for billions of years. Patient, steady, holding you. Nothing requires your attention right now. Nothing needs to be solved or understood or remembered. You've learned enough for one night. You've wondered enough. You've travelled far enough through time and space and possibility. Now it's time to rest. And you deserve rest. You really do. Not because you've earned it or accomplished something. Just because you're here. Because you exist. Because rest is your birthright as a living thing. The universe doesn't need you to stay awake. It's okay. Everything will continue without your awareness for a little while. The stars will keep burning. The earth will keep spinning. Time will keep flowing. And you can drift. You can let yourself go soft and loose and heavy. Let your thoughts become slower, quieter, like they're moving through warm water. There's nothing to hold on to, nothing to grip, nothing to figure out. Just this gentle dissolving, this sweet letting go. Your breath is all you need right now. In and out, slow and easy. Each breath taking you deeper, softer, further from the questions and closer to sleep. And sleep is good. Sleep is healing. Sleep is where your mind sorts through everything you've learned, everything you've felt, everything you've wondered about, but you don't have to manage that. Your brain knows what to do. Your body knows how to rest. You can trust it. You can surrender to it. The mysteries we talked about tonight, they're still out there. Deep time is still unfolding. The universe is still vast and strange and full of things we'll never understand. But that's not your job right now. Your job is just to be here. You're part of something ancient, something continuous, something that was here long before you and will be here long after. And right now, in this moment, it's holding you, rocking you gently towards sleep. Let it. Let yourself be held. Let yourself be small and safe and temporary. You don't have to be anything else. You don't have to know anything else. Just rest. Just breathe. Just be. Thank you for wandering with me tonight. Thank you for your curiosity. Thank you for being here. But now, you can go. Drift away. Follow your breath down into darkness, into quiet, into the soft nothing of sleep. I'll be here when you come back. The questions will be here. The mysteries will wait. But for now, just rest. Sleep well, wandering wanderer. You're exactly where you need to be. The universe is vast. Time is long. And you're safe. You're held. You're allowed to let go. Good night.